Hi guys, and welcome back to this STM32 beginner series. In today's episode, we're gonna get hands-on by building our first project where we're gonna be blinking an LED using the GPIO pins in our STM32F401RE microcontroller. By the end of this video, you should have a solid understanding of how to control basic peripherals like an LED using your microcontroller. My name is Ali and you are watching CGHQ. Let's start with a quick overview of GPIO, which stands for General Purpose Input Output. GPIO pins are versatile and can be configured as either input or output depending on your need. These pins are how your microcontroller interacts with the outside world, whether it's reading the state of a button or controlling an LED, for example. Each GPIO pin in the microcontroller can be configured in several modes. The first mode is input mode, where the pin reads a voltage level from an external source. The other mode is an output mode, where the pin outputs a voltage level, for example, to turn an LED on or off. Another mode is an alternate function mode, where the pin is used by an internal peripheral like USART or I2C. And then finally, we have analog mode, where the pin is connected to an analog to digital converter, otherwise known as an ADC, or a digital to analog converter, otherwise known as a DAC. Before we can actually start coding, let's talk about hardware abstraction layer, HAL. So HAL is a library provided by ST Microelectronics that simplifies the process of configuring and controlling the STM32 peripherals. It basically provides a set of functions that allow you to interact with the hardware without actually having to directly manipulate the microcontroller's registers. A question you might ask is, why should you use HAL? HAL abstract the complex low-level details of the microcontroller. This essentially makes it easier for you to develop applications. So instead of writing code to manipulate specific registers within the microcontroller itself, you can just use HAL functions that are more intuitive and easier to understand. This basically allows you to focus more on the application logic rather than the hardware specifics and the general architecture of the microcontroller itself. Even though HAL simplifies things, it's very important to understand what's happening behind the scenes, to understand what's happening inside the microcontroller itself while you are busy working on your project. At the core of any microcontroller, there are registers. Registers are basically small memory locations within the microcontroller that control the operation of the microcontroller itself. For example, there are registers that control whether a GPIO pin is set as an input or an output, and there are other registers that determine whether the input-output pin should be set high or set low. Inside of each register, there's a collection of bits going from the least significant bit to the most significant bit as you move from right to left. Each bit or group of bits in a register controls a specific function. When you use HAL, it's essentially manipulating these registers for you, but in a way that's more user-friendly. To give you an idea, if you weren't using HAL, you might have to write something like this highlighted code over here to set a GPIO pin high. What's happening in this highlighted code is that the fifth bit of the output data register, the ODR register for port A, has been set. While this is efficient, it can easily lead to errors and it makes the code harder to read, especially for beginners. However, with HAL, this same operation is done with a function call, which is much more straightforward and much more readable. Using HAL, the equivalent code from the previous slide would be shown as highlighted in this code. This function is much more descriptive. It abstracts away the complexity of directly manipulating the registers. As a beginner, this makes your code easier to write and understand. As we progress through this video, I will explain to you what exactly is happening in this code that I've written on this slide so that you can understand what each and every single line of code is doing in your code as you use these HAL libraries. To start a new project on the STM32CubeIDE, you're just gonna click on the software, STM32CubeIDE, and then it says select a directory as a workspace. You can just select the default one, or you can browse to choose the folder in which you want to save your workspace. I'm just going to leave it as it is and click launch. and then you're going to be greeted with something that looks like this. So you can come here and say create a new STM32 project, or you can come here and go to file and select new STM32 project, and then we're going to be greeted with this screen here. So this first tab here says MCU/MPU selector. This is where you can search for the type of microcontroller that you're using. However, if you go to the next tab which says board selector, you can also search for the type of microcontroller that you're using. The difference between these two tabs is that here under MCU selector, you can search for any type of STM32 microcontroller, including the ones that are not actually manufactured by ST Microelectronics. So you can search for microcontrollers that were developed by third parties. And then if you go here to board selector, you can find boards that were directly manufactured by ST Microelectronics. But here under MCU selector, you can also find boards that were directly manufactured by ST Microelectronics. It just gives you the option of searching for ones that are developed by third parties as well. So we're just gonna come here to board selector, and then here where it says commercial part number, we're just gonna search F401RE because that is the board that we're using. And then here you see the picture of the board. We're just gonna click here, and then we're gonna click on next. And then here it says project name, so we can just call this project LED blink, and then you can either choose to use the default location for your project, or you can click uncheck this and then click on browse to select where you'd like to save the file. So for now I'm just gonna use the default location. And then the targeted language, we're gonna be coding in C. The targeted binary file type, it should be executable, and the targeted project type is STM32Cube. And then we can just click on finish. Great. So when this is done, we are greeted with this user interface here. So these are all of the pins in the microcontroller that we are using. So you can click on any of these pins and configure them however you'd like. And then here on the left side here, we have a bunch of stuff such as system core. Here we basically have GPIO pins. We have a bunch of stuff for interrupts and watchdog timers. You don't really need to worry about that now. Here we have ADCs, and then we have timers and stuff. And then if you go to the next tab to clock configuration, this is basically where you can configure the clock of your microcontroller to a value that you want. So there are high speed internal RC oscillators, high speed external oscillators. You can pretty much configure this however you want to suit the need of your own project. And then here we have project manager, and then here we have tools. Here you can basically do simulations and a whole bunch of other things. I personally haven't used anything that is on this tab. So we can just go back to pinout and configuration. So for the LED that we're going to use, we can just choose any of the pins that we wanna use here. So I'm just gonna go ahead and use pin PB5 if I can find it. So I'm just gonna say this is pin PB5. So the reason why I'm choosing pin PB5 is because if you go to the pin out on the microcontroller, I'm just gonna use pin D4 on the actual microcontroller itself, and pin D4 is labeled as PB5. So on this IDE, I'm just gonna go to PB5, and then here you can choose how you want to initialize this pin that you're using. So we want to initialize it as a GPIO output pin. So you're gonna select on GPIO output, and you can see the button is green. When it's green, it means that it has been fully initialized. So after this is done, you just need to go to file and then click on save, and then ask you, do you want to generate code? We're gonna click yes, so that the system automatically generates initialization code for this pin that we just selected to use as a GPIO output. So we're just gonna click on yes, and then we're gonna click on yes again. When that is done, we're gonna be greeted by this window here. So already there's a lot going on here. We haven't started writing code yet, but already there's a bunch of stuff in here. But you shouldn't be intimidated by everything that you're seeing in here. So basically what's happening here, this is just to include the main header file, and then we have a bunch of stuff that we don't really need to get into. The only thing that we need to be concerned with for this episode is this main while loop here. Okay, so essentially what's happening here is that let me just see if I can zoom in properly. Essentially what's happening here, here it says initialize all configured peripherals, and then we already have this function here. This function was automatically created for us after we selected that pin to be a GPIO output. So this is, if you click on control and click on this function, it'll take you to this C file where you can see exactly what's happening inside of that function and how the pin that you're using has been configured. So if you can just scroll up here, one thing you need to be careful about is these comments here. These comments are not useless. They've been put into place for a reason. So you see in between here it says user code begin 2 and user code end 2. This is where you're supposed to be typing in the code, your own personal code. If you type it outside of these comments that says user code begin and user code end, when you try to refresh your project or save a new version of your project, it's going to get rid of all of those ones. So for example, let's just make an example and say int variable is equals to 25, and then we can just do a semicolon. We can just call this one let's just say save variable, and then we're gonna copy this, and then we're gonna put another one that is outside of these two comments, so I can show you what happens if you don't write your code within the designated areas within this script. So we can just call this one unsave variable 2, and then we can say it's also 25. That doesn't matter. So what happens is that if we go back to this IOC and then we initialize any other pin, for example, let's just say PA5, maybe GPIO analog, for absolutely no reason. I just want to show you what happens. And then we go back here and we say save and then generate code again, and we click yes. When we go back to our actual code, you can see that the code that we wrote in between these comments that says user code begin and user code end, we still find it there. But the one that we wrote outside of these comments that say user code begin and user code end has been removed. That is why when you write your code, you must be careful and only write code in these areas where it says user code begin and user code end. Okay, so I'm just gonna delete this because we don't really need it. Okay, so now to get to the main project, which is blinking an LED, we need to come to this while loop here. This is an infinite while loop. So your code, when it gets to this point here, is just going to keep looping and looping and looping. So it says user code begin 3. So what we're going to need to do is just is that we're going to write our code here on this section here. So to blink an LED, there are two types of ways you can blink an LED. You can turn the LED on for a couple of seconds and then turn it off again for a couple of seconds, or you can automatically toggle the LED on and off. So we're gonna explore both of these ways. So the first way that we're gonna explore is that we're gonna use a HAL function. So we're just gonna type HAL underscore GPIO, and then what we're gonna have to do is that you can hold control and then click on space, and it's going to show you all the available functions that start with HAL underscore GPIO. So as you can see, we have a bunch of different options here. So the one that we're going to use is this one here. So you're just going to double click and it says HAL underscore GPIO underscore write pin. So here where it says GPIO X, the pin, remember the pin that we used is PB5. So let me just write it here. It's PB5. So if it's PB5, it means it's GPIO B, because of this B over here. And then GPIO pin, the pin that we're using, we're gonna write GPIO pin underscore 5, because we're using port B pin 5. and then here we need to set the state that we want. Do we want the LED to be on or off? If you want the LED to be on, you just need to erase this and write 1. If you want the LED to be off, you can just write a 0. But for now, we're gonna write the LED to be on. So we don't want the LED to just be constantly on all the time. We want it to turn on, and then after a certain time turn off, and then after a certain time turn back on again. So to achieve that, we need to add a delay to specify the time that we would like the LED to stay on. So to do that, you just need to type HAL and then underscore delay, and then you can just click Control and space, and it will show you the options that you have. So you're just going to click on this one that says HAL underscore delay, double click on that, and then remember to put a semicolon at the end. So the delay that you need to specify is going to be in milliseconds. So if you'd like a 1 second delay in between the different states of the LED, you can just write 1000 here, because 1000 milliseconds is 1 second. And then this essentially what we have here. We have this pin 5 that has been set high, set to a value of 1. What we want to do now is that we want to take this exact same code, paste it below here, fix the indentation a bit. Now after 1 second has passed, we want this pin to be reset to a value of 0 for 1 second as well. So what's going to happen is that when the code is running, the pin is going to be set to a value of 1 for 1 second, and then it's going to be set to a value of 0 for 1 second, and the loop is going to keep repeating over and over and over again. And then to confirm that our code is working without any errors, we just need to come here to this icon that looks like a hammer, and then you're going to click on that. You're going to click on that hammer to build the project. And then if you see here, it says finish building with 0 errors and 0 warnings. So that means the code that we've written has no errors and no warnings, and we can go ahead now and connect the microcontroller to the laptop, build the circuit, and actually see the LED turning on and off. Okay, now let's build the circuit to blink the LED. What you're gonna need for this setup is a breadboard, the microcontroller itself, an LED, and a current limiting resistor. The value that I have for this resistor is 220 ohms, and then you're gonna need 2 jumper wires. The first thing that you're gonna have to do is that you're gonna have to take the LED and connect it to the breadboard via the resistor. So what's gonna happen is that the long leg of the LED is gonna be connected to the pin that we're using, which is pin D4 labeled on the microcontroller, and then the short leg is going to be connected to the ground of the microcontroller via the resistor. Then when you're done connecting the circuit, you're just going to need a USB cable like this one here. So you're going to take it and connect it to the microcontroller, and then you're going to connect the other end to your laptop or your computer. After the microcontroller turns on, we can go ahead and upload the code on the microcontroller. When you're done connecting the circuit and connecting the USB cable to the microcontroller and the computer that you're using, you just need to come to this green play button here that says run. And then when you click on it and you go to the debugger section, you will see a bunch of options here. So what you can do is that here where it says interface, you can click on interface on ST-Link S/N, and then you can scan so that the device can scan for the ST-Link that is connected to your microcontroller. And then from there you can just click OK, and then here you see it says waiting for debugger connection, and then we can just look at what's going to happen here at the circuit. So you see after it says download verified successfully, shutting down and exit, the code has been uploaded to the microcontroller and the LED is blinking like we programmed it to blink. So that is one way to blink an LED. Another way to blink an LED by using 2 lines of code instead of using 4 lines of code is that you can actually come here, remove all of these lines here, and then you can actually say HAL underscore GPIO, and then you can click on Control and space, and then instead of using the right pin, we can actually use the toggle pin function. So just double click on that, and then here we need to specify the GPIO port that we're using. So we're using port B, and then the GPIO pin that we're using is pin 5. So it's just going to be capital PIN underscore 5, and then don't forget to add the semicolon because we're using PV5. And then essentially what this function is going to do is that every time the code enters this function, it's going to check the previous state of the pin that you want to toggle. So if the previous state was set to a low value, it's going to toggle it to a high value. If the previous state was set to a high value, it's going to toggle it to a low value. So it just keeps changing between those two states every time this code is executed. So now we need to add a delay as well so that we can see this happening. So what we can do is that we can say HAL underscore delay. Sorry about that. We can say HAL underscore delay control space, double click on this first option, and then we can actually just say maybe 250 milliseconds at the semicolon, and then we can go ahead and run the file. So as you can see here on the microcontroller, the LED is still blinking from the first code that we uploaded. So we're just going to click on OK, wait for the code to finish building, and then waiting for the debugger connection, and then it says download verified successfully. So you can see now the LED is actually blinking at a faster rate than the previous code. So this is the second way that you can use to actually blink an LED, by using 2 lines of code instead of the 4 lines of code. In this episode, we've learned about GPIO, HAL, and registers. We've set up a simple circuit and wrote code to blink an LED. This is a foundational skill that you'll build upon in future projects. In the next episode, we'll take this one step further by introducing PWM, or pulse width modulation, to control the brightness of an LED. Thank you so much for watching this video. If you found this video helpful, please like, share, and subscribe. And if you have any questions, please drop them down in the comments below. And I'll see you in the next episode where we'll explore PWM and LED dimming.